Pairs go outside, leftovers go in the box. Okay, and if I type this in, the calculator won't give me this answer, but it will be the same decimal as what I started with. Okay, that's how I know I did it right. Okay, if you're not sure, try putting the 5 outside, and look, I don't get the same thing. Okay, so that's a way that the calculator, again, it won't do the problem for you, but you can check yourself. All right, dos más. All right, number 9.
Number 9.
Okay, square root of 34 over 3. All right, one of the rules, well, first of all, try doing it in the calculator. Decimal. Okay, try just 34 divided by 3 in the calculator. Or also a decimal, right? Either one. Okay, so we're going to do something else to fix it. So we're going to use the G. G is the rule up here where it's really square root of 34 over the square root of 3. Okay, we're breaking it. We're doing it the opposite way. Now, one of the rules about radicals is that you cannot have a fraction underneath the radical, right? And it's not the right form. You can't end that way. You got to keep going. And you can't have a radical on the bottom. Okay, so to get it the right way is that we need to get rid of a fraction that we don't like. Remember, you multiply by what's on the bottom. Okay, so but we can't just multiply the bottom by what's on the bottom. We need to multiply, the whole thing has to be multiplied by 1. We can't just change it. Okay, so to multiply by 1, it has to have the same on the top and on the bottom. Okay, so we're going to multiply the top and the bottom by what's on the bottom of the fraction. Okay, and when you do that, real quick, I'll show you. Square root of 3 divided by square root of 3 is 1. Like I said, we just multiplied times 1. Sorry, you can't see that. Okay, and then now multiply 34 times 3. 102. Okay, that stays in the square root. And square root of 3 times square root of 3. Oops. Oh my God, why is this happening to me? So embarrassing.
I'm so confused.
Okay, we'll go back.
Why do we multiply those?
We're multiplying by, you can't have a radical in the denominator. Okay, that's just a rule about radicals. It cannot be in the denominator. Okay, so to get rid of it, we multiply by the same thing. Okay, on bottom. But you can't just multiply one part of the fraction by it. You've got to multiply the whole thing by it, because this, anything divided by itself equals 1. Okay, so if you multiply, you can multiply by 1 all day and you're not changing it. You're changing the way it looks, but you're not changing the fraction, or you're not changing the problem. So if we multiply top times top, 44 times 3 is 102. Square root of 3 times square root of 3 is 3. It gets rid of the square root. Okay, and it leaves us without a radical on the bottom, which is what we need. Radical on the top is okay. All right, this is the same thing. Is the same thing as what we originally started with. Right, it still means the same thing, but this is the proper way to write it. Okay, we can't have a fraction underneath there. We can only have a whole number on the bottom of the fraction. Okay, it's just a rule about radicals. It's still like a month and a half away. And okay, one more. Number 10. The 7th root of 384.
Did we put a letter on this 8?
We didn't do letters on 8, 9, or 10 because they're not necessarily one property. All the ones before that were demonstrating one of the ones. Okay, so as I've said before, if you have a big number like this, try it in the calculator first. Okay, so 7, math, 5, 384.
Yes.
Decimal, okay? If you get a decimal, ugly, okay? Try it this way. right? And I don't know all the factors of 384.
1 and
Right.
384.
All right, 1 and 384. I'm going to try 2. That's right. Okay. But I always like to start with the smallest one. Okay. So I don't miss any. So it's easy to try.
192.
You could, but I think it's easier just to do 384 divided by 2.
That is 2 and 192.
192. Okay. 192 you can tell is even. Okay. So that's 2 times
96.
96. Okay. That's even. So you know it's going to be 2 again. Exactly. 48. Okay, another one. 24. 12. 6 and 2. 2 and 3. All right, and there you go. Now everything on the ends of our branches are prime. How many do we need? 7, right? How many do we have? 7. Okay, 7. What goes inside?
2. I mean,
The 3 is left over. 3 is left over. So it's 2, 7, 3. Okay, and again, you can check this. 7, math, 5, 384. 2 times 7, math, 5, 3. Same thing. Okay, so 2, 7, radical 3. Okay, that's the last one. We